Well, hi, good morning, and thank you so much for joining me in my shop. Today is June 15th, and before I go any further, let me say this is my second introduction to this video. For some reason, I don't know, my first 10 minutes of working in the shop, I recorded no sound at all. And during that time, all I was really doing was talking about these buttons and installing these LED lights and doing a little oiling here and there. So nothing too serious went by during that time. And then the rest of the video fortunately has sound on it. I have no idea what happened. I'm going to blame it on a cat. That's what I can do. So somehow the cat ruined the sound on the first 10 minutes of the video. So I've dropped all that, and we're just going to jump right in where there is sound. And I think there might be one segment that's silent. It's only about a minute long. No, I think I deleted that too. So sorry, you're going to miss the very, very start of this video, but that won't matter because what happens later is a lot of fun. I can't remember if I lubricated the tuning capacitor or not, so I'm going to do it now. A number of spots to do in a radio like this. Anywhere. Here's a shaft in a sleeve. I think we want to get rid of as much resistance here for the sake of the motor. And that I don't know what I call it, buzzing sound, that's the gears spinning rapidly underneath as I tune it, because this is gear driven tuning with a string driven pointer. Is it? No, it's string driven tuning also. Okay, now there's also some grounding parts in here. There they are. There's some ball bearings back here. Strings are in the way here. That's a blast. Actually, it feels not too bad. I mean, it takes a bit of work. Other radios are just completely, feather light. This is not. There's no flywheel. You're not going to do any of this kind of stuff with this radio. Okay, I never did find the fuse. I just remembered the fuse. What, is it rolling around in here by any chance? I thought I saw it on my bench the other day. I thought, hey, there's that fuse. But it's not there now. Okay, I think this is probably is. Put just a little dab right here. It's hard to do a little dab of this stuff. There, that's a dab. This one's been oiled before. Okay, now there's a lot more mechanism all back in here. The whole thing is airborne back here. There's no supports or bushings or anything. So the when you tune the radio and you see some of these plates moving in the tuning capacitor, you might think those plates are the sort of the electrically active plates, but in fact they're grounded to the chassis or grounded to the B minus. The B minus line in the radio. It's the fixed plates that are actually insulated from the chassis, and these are the ones that are electrically active, if you put it that way. I don't know if you can see it. Can you see this? You can see there's the plates are split here. See, there's a split in it right there. So there's a section here, a section here, there's a section up here. Those are just the outside plates of the capacitor. And this was a sort of a last ditch opportunity to change the tuning linearity of the radio and change the capacitance of these capacitors. And you could do it sectionally, so you could kind of end up adjusting the pointer position very, very precisely. And so I think. In some radios, these are bent out quite a bit, but not in this one. They've never been bent in this one, and I'm not about to bend them. Okay, I've delayed everything as long as I can. Time for that coffee. There's quite a bit of stuff in here that we really have to go through and understand in order to gain complete control over the mechanism. And if it doesn't work right, understand what's going on with it. So let's just read this thing. I'm sorry to do this, but I think it's very important to do it. So we're just going to read through here. The circuit of the electrical tuning mechanism is shown in the schematic diagram, and the mechanical details are illustrated below. The action can be understood by following a cycle of operation. When a station button is pushed in, it completes the 24-volt circuit through the corresponding station setting contact and 1/2 of the brass selector disc. This is connected to one side of the motor field coil. This energizes the motor, and the rotor is pulled forward, engaging with the gear train that drives the tuning condenser and selector disc. The condenser and disc rotate until the insulation line comes under the particular station setting contact, and the motor circuit is broken. Inertia carries the insulation line past the station setting contact, which then makes contact with the other half of the disc. This completes the circuit on the other side of the motor field coil, causing the motor to reverse. The floating flywheel is still turning in the original direction and therefore slows down the reversal movement of the motor. As a result, the selector disc is moved slowly back until the insulation line is under the station setting contact. When the circuit is broken, the mechanism stops. Adjustment of flywheel friction. In normal operation, the motor drives the tuning condenser and selector disc until the insulation line just passes the particular station setting contact. The motor then reverses and moves the disc slowly in the opposite direction until the insulation line is under the contact, and the mechanism stops. In some cases, particularly with high line voltage, the disc may make 2 or 3 reversals before stopping. The flywheel friction adjustment screw should be set to give the least number of reversals with the chassis in normal horizontal position. The flywheel friction adjustment screw. Well, chances are we're not going to make any adjustments at all, and we're going to find out that this thing works just as it is, works good enough just as it is. But it's good to know these things exist. Adjustment of the selector disc. The brass selector disc is fastened to the rear shaft of the tuning condenser by means of 2 set screws. When the condenser is at a maximum, plates fully meshed. The insulation line should be horizontal and the operating end at the left viewed from the rear. What? The operating end has dark insulating material and the brass is beveled at this end. The operating end. I don't know what they're talking about there. The selector disc should be set so that the contact tip plungers in the station setting contacts project no more than 1/16 of an inch from the body of the contact. Again, I guess if things are way out of whack, this is the kind of information you use to get them back into whack. I don't think anything is way out of whack at all. But they have to give you the whole story, don't they? Muting, this is the part that got me reading this. Muting circuit. I almost fell over when I saw this. When the electric tuning mechanism is in action, the motor supply voltage is fed into a diode rectifier circuit, which applies a high bias to the IF and first audio tubes. This prevents audio amplification and makes the set quiet or mutes it while the mechanism is operating. So they're taking some of the motor voltage, rectifying it, and then applying it as a bias. to shut to turn off the to stop the radio from making sound. Because I guess as the tuning, it would be tuning through all the stations, wouldn't it? The motor would be driving it along, and you would just hear one station after another being tuned through. So they wanted to get rid of that. This is the technique they used. Lubrications: pure oil number 611 or petroleum jelly. Make a list of the stations you want. Left hand push button is the Victrola attachment, the record player switch. The right hand is for dial tuning. So if you want to use the dial tuning, you need to push in the right hand button. Well, no buttons are pushed in right now on this radio, and I've been doing the tuning with no buttons pushed in at all. I think theoretically there must always be one button pushed in, because it's the act of pushing in a button that releases a button, but you're pushing in one, so there should always be a button to press on this. But not necessarily. I mean, you can fiddle these things and make the release bar move and then release all the buttons, so there's no buttons. Sometimes if you push a whole bunch of them down at once, I wouldn't want to try that. That sounds like a bad thing to do to me. Okay, they've given some wire colors down here and station button numbers and the color of the lead, so you can look at the wire here and figure out which wire's what. Good luck on that, because the colors fade out. Armchair control unit. So there is a remote unit. We don't have it here with this radio, so I won't bother reading that. The armchair control. Adjustments for electric tuning. Turn range selector to A, band turn on power, allow a few minutes. Press down dial tuning right hand button. Manually tune first station on a list. So at this point I won't follow this because the buttons are set. We'll just push all these buttons and see where it goes. And see what happens, see what we pick up. Lots and lots of information here. Look at how complicated this all is. Now, I think we noticed before, the motor shaft is supposed to be driven. This part should be driven into the gear here, and the motor didn't throw it. Now, one possibility is I wasn't operating the radio on full voltage, and so the motor wasn't getting 24, it was getting 20, and it's just not enough to kick it forward. There is a spring, they show it right here, a rotor spring right in here, that pushes this back, because you've got to this is tricky stuff. You have to disengage the motor for manual tuning. So when you do manual tuning, you're not also rotating the motor. There's a gearing ratio here, so if you move the dial, the tuning control with your hand a little bit, this motor would be spun quite a bit. You'd feel that in the control. It wouldn't feel good at all. So they come up with this method of disengaging it. It's really like first thing somebody thought of. That's kind of what it looks like to me. So this may not work based on our earlier observations. The motor may not engage with the gear here, and we can't see the way that I have the radio. I have the radio in its normal position. These are the spring-loaded things. Component parts of station setting contact, drive cord arrangement. Right. Nowhere do they give actual instructions on how to work. How to adjust these things. They don't say. Nowhere. It just doesn't actually say. It just says move it. Central dial lamp will go up. Press down. That's right. If you hold down the end button, then you go into this mode where the light operates. We should maybe do that first. Push this button down. Push some other buttons. But the motor won't operate, so no, we can't do that. Doesn't make sense. We should just push these buttons and see what happens. Okay. I mentioned before, I have a. It's my nature to delay things which may not work out well. I'd rather leave it as a question mark sometimes than find out if it's really going to work. But we're going to find out. We are going to find out. Power's off. Plugged in. We're in the dim bulbs. There we go. The thing about these lights is they draw much less current, so the transformer here will work just a little less hard. Won't make too much difference in a big radio like this. Volume up, please. And we are on the A band. And they do have the antenna connected. Did I turn the volume up? It's just, the volume is really lacking. Like, you know, you should be like, wasn't this low the other day. Yeah, that's full volume. Am I really on the A band? Yeah. Oh, I'm in the wrong end of the band. It should be up here. Get stations up here. That's all the volume there is? How come? Seems like over the period of time that I've been operating this radio, it's gotten lower and lower volume. Oh, I know what it is. I don't have I got the dim bulbs on. Jim. Wow, that's a little brighter. 115 volts now. That's a good test voltage. Okay, got a little more volume. What's probably going on is, as time is going by, I'm getting duller and duller, and that's what's happening.
The FBI has offered a reward for his capture. Time for sports from Sportsnet 590 The Fan. Here's Colin Teskey.
Canadian Grand Prix set to go.
640 with interference. I'm not sure what that is. Well, I got it wrong. Okay, so this is 860. I got it all wrong. Start rate at the start. So this is a weak station it's picking up. Again, good antenna, makes all the difference.
I feel like
Beautiful.
once you get past,
That's 590. Okay,
Yankees are probably one, right?
we're ready now. So, chances are this is the low end of the band, this is the high end of the band. We're at the low end right now. Push one of these buttons, it won't demand too much. I don't have the fuse in it yet. Okay, I have to find the fuse. Okay, I've got a 3 amp fuse here. I'm just going to turn the radio off briefly while I pop this in. Don't know if doesn't fit. That's too long. It's too long of a fuse. Need a shorter one. These look really short. 3 amp. This looks really short. No, it's too small. What's going on here? How did this happen? How dumb of me to have lost the fuse I had. I'm a little bit surprised here. These, I didn't think there was that many different sizes. This doesn't even fit in the container. This is different. Well, I don't get that. This is just slightly longer than, seems like you just never know. That's what, that's what it turns out. Let's turn this back on. Okay, motor didn't jump into life. That's good. I wouldn't expect it to. I gotta push a button to make it go. Notice this light's on. That's supposed to be on. Dual purpose light. Interesting question. You have to be able to see this light. Like we can see it now, of course. I got it on my bench, but later when the radio's together, you got to be able to see this light. It can't be hidden. So I think probably it's just becomes one of the three lights lighting the front panel, and then has a dual purpose. Okay, I can't delay this any longer. What do we want to watch for? So we want to watch the capacitor or any of the mechanized portions. So this is going to turn, this is going to turn, and inside here this plate is going to turn. It's all going to turn, 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 turn. I want this to turn on. Here we go. So the motor didn't engage. It's running, but it didn't engage. How do you stop it? Stop this crazy thing. Ooh. Ooh. That didn't sound very good. Okay, our first run at it. We got exactly the result I expected. It did not engage. And the other thing is, ooh, wow, sounds like it really needs a bit of lubrication. We're going to shut it off, let things cool down a bit. We'll take a look at the motor underneath and see about that terrible sound. So at this point in time, I'm really not sure what to do about this. We're going to disconnect the, this was just to operate the meter over here. So one big problem is this just didn't travel forward. And if there's a spring pushing it this way, it's not very strong. Like there's almost no resistance from a push it either direction. It feels almost the same. So the spring is just very light, and you would think with it spinning, like just disengage it. If it's spinning, it would drift back this way. Yeah, it did it right away. Yeah, right away the spring throws it back. So it has to overcome that spring. Wow, that's not much at all. Why will it not do it? I also noticed the motor came up to speed rather slowly. Motor circuit. Is there anything in the motor circuit that could somehow control or reduce the power coming to the motor? Here's the motor. Poor contacts out here. That might do something. There's a capacitor right there. I haven't done anything about that. Maybe that does something. There's another one over here. These are probably noise absorbing capacitors, because the motor's going to maybe generate a bit of noise, electrical noise. I don't know though. Maybe they have something to do with the motor itself. Motor selection disc, station setting contacts, and then the power's coming right from this 24 volt winding here. So we should check and see if that's really 24 volts. And then it comes up and then it just goes through the switches, comes out, goes through the rotating disc, and then into the motor. So there's no resistors, just these capacitors. So this one I'm sure is right somewhere. We already saw it. It's right up in here. So I'm going to go after that right away. Well, I don't have to be careful moving this now. There. Okay. Where is it connected? I can see one side appears to be connected here. Oh, there's two capacitors right there. There's two of them in there. Oh, really hard to get at. That's probably the two 0.01s. It appears that the capacitor wire goes up through the chassis and up onto the top. I can't rotate the radio easily anymore because I didn't put it on my turntable. And all I have handy is just my little tiny mirror. What do I want to take a look at? Forgot what I was going to look at. So voltage, capacitor, that's right, I wanted to know where the capacitor went. Man alive, it's pretty easy for me to forget what I'm doing. This isn't going to work out. I can't see enough with the mirror. Okay, I'm going to put this back up on the turntable here. I actually thought to myself, why don't I just set this up on my bench without the turntable? And because I almost never do work without the turntable, and I should find out about that. And here it is back on the turntable. Okay, so we can spin this guy right around. Okay, so it looks like a capacitor comes right up and connects here. That's what it looks like. I can see the black cover, so that I can mimic that. That's no problem. And the other capacitor, bit of a tangle up here. The other capacitor, well, one terminal's here and the other one is hidden from view by the, no, you know what, it's on a sleeve. It's going up above too. It's coming up on a sleeve, and I bet you it's right in here and I just can't quite see it. Wow, I still don't see it. It'd be coming up here too. The two of them connect to the same spot. Why? Whoops, sorry about that. Why would they do that? No, one is connecting to one winding, the other is connecting to a different winding. Both grounded at one end. So can I see that? So this is not the grounded end. That's got to be the motor. I don't really know what these are. They look like they're just motor power terminals, but maybe it'd be a little bit, yeah, there's more terminals down here. I hesitated because the wires coming from it are going to this switching apparatus. They're not a source of power or power going somewhere. It's just going to a switch. And the other side would appear to be on a, oh, definitely grounded. There's two grounded terminals under here and the two capacitors are connected. Heavy braid. Okay, I can get those out of there. I think I know what's up. I think I know enough to get into trouble here. So they're identical grounded terminals, so it doesn't matter. Who put this motor in the way here? Okay, I'm ready to cut something. Hopefully that was the right thing. We come from the top now. one. Let me pick it out of there a little bit. Pretty tight in here. Can't really. I'm trying to separate it from other nearby wires so I don't cut too many wires at once here. Ooh, I don't like it. I feel like I cut a bunch of stuff. Oh my gosh, what's happened there? Is this not what I thought it was? Should be able to wiggle the capacitor from underneath now. I can barely move it. Oh yeah, it's definitely. Oh, I did it. It's okay. It's okay. Everything's okay. Let's see if we can get it out of there. Come on out. Come on out. Enjoy the sunshine. There you are. We're going to test this guy for sure. And then the other one, now I can get a better look at the other one. I'm going to nip it and leave the wire. We'll worry about where the wire goes later. Oops. Just want to nip it with enough wire we can test it. Nip this so short, we won't be able to test it. I can get in there. No, can't get it. Okay, where's it going at the top? It's going to exactly. We got a good pull on it now. It's going up. I believe it's coming up on the inside of these wires where you can't see it. Yeah, there it is. Okay, so I can get in there. So it's each capacitor is going to one of the two motor terminals and then to ground. These are probably the field. These are probably the two different field terminals that cause the direction of the motor to change. Well, what did you do with your cutters? Just like that, disappear right out of your hand. Just boom, gone. Gone for good. Okay, calm down, Jim. Just bring it down a notch. Okay. I'm a little too excited. I'm trying to feel that capacitor again. Where are you? Way up here. I don't want to bend any of these wires too much because that's it right there. Just go right there and go. And that would be it. There we are. We got them out. Let's give them a test. So I really don't know if this can be responsible. These capacitors can be responsible for the failure of the motor to operate as it should. What are they in there for? I think they're in there for noise control, but I could easily be wrong about that. Noise control. When the motor's operating, the radio is shut down, so there's no reason. So there's a much bigger noise control going on. You can just barely see the pie down here. My new camera just doesn't quite cooperate on this. What if I blast it with light? Does that help? Or does that hinder? It really doesn't help much. Hey, there's a sweet spot here. Okay, so you can see the pie well enough. Here we go. 50 volts. What do you say? Open right up. Son of a gun. 150 volts. Open right up. Oh my gosh. These are in good shape. This one's in good shape. Ay, 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 ay. I didn't want to see that. Maybe the other one's bad. Okay. Could be these capacitors are good because they're almost never operated in the radio. Almost never. So here we go. 50 volts. What do you say? Right open. Well, okay, so this one's not quite opening, but you know, motors draw heavy currents, little tiny leaks in the capacitor. What can that do? I wouldn't even know it's happening. The motor wouldn't even know it. So, I mean, there's some phasing effects, but I will replace them, but I would not put money down on this. You know, I will put this down. I have one American penny here. Yeah, there he is. Bet you an American penny does not. Changing the capacitors has no effect. Okay, I'm going to let the video play while I put this in. The first thing I'm doing is I'm joining the capacitors together at one end, because one end is grounded. Turn it into that. I'm going to push this up where the others were. It's very important this be on. Should I have these on when I'm shoving it up there? Here. Okay. Gives me a length and position. Now I can bring this down to the ground terminal here. Which is that's gonna work. Let's go back up on top and see what's happened. Okay, this one pretty much stayed in place and can be soldered. Do with your solder. Here it is. Penny's still there. break. Yeah, this is about just about the right time now for the string to break. Just burn it just like that. Oh, that was that cat thing there. Somewhere else in my house. Okay, there it goes. Okay. Now, let's ask ourselves this question. If we operate this on its side like this, is it really different? Would it behave differently than otherwise? Do I have to lay the radio down every time to try to test it? We get a false impression if I... just one second. I just need to check something here. Not soldered. I didn't solder this, did I? It's not that I did a bad job. I hadn't done it at all. Great big terminal here. Here we go. Okay. So what we'll do about the can you operate this radio on its side, or is that going to give you a false impression? We can try it like this. We can observe the motor and everything. Once it's laying down, boy, it really does hamper the whole thing. So I'm going to throw a little more lubrication in there. Use this very light oil. Oh, squeezing air on it. Pretty good, eh? Just a little sticky at the start. I have to push a little hard. Maybe I can demonstrate this. If I get something weak, what have I got that's really weak? Maybe a long rod here. So what I'm trying to show is you can push. It's sticky. You push a little bit, and then it goes. And so I think that demonstrates the stickiness. It's not much. Is it sticky because it's dirty in there? Oh, I think it's just ordinary friction, but let's put a little more oil on it. Okay, there's just nothing restricting this from getting over there. So, yeah, it comes back on its own for sure. Okay, we're ready to try it again. Now I do not have the speaker plugged in for this. Where'd the plug go? Where's the plug? There it is. Okay, so No buttons are pushed. Okay. These LED lights are pretty bright. That's good though. Okay, I'm going to push one of these buttons and we're going to see the motor do its thing. What's liable to happen? It's liable to sit in this spot and spin. Is there any chance? I'm sure this is level. I can't imagine it's off level. Yeah, it's level. Okay, we should turn down the volume for some reason. Okay, push the button. Push a button. No, I don't want to hold on. I'm a scaredy cat. I just can't bear to touch this metal and be hanging on to the chassis at the same time, so we'll do it like this. Here we go. Better. And let's stop. How do you stop it? Or release the, flip the releaser. Motor's running good. But it did not get driven forward. You have to install this radio on a slight angle. But if you did, if you actually tip the radio forward so the motor's falling in, it might not go back afterwards. And I'm not tipping the radio is just a goofy idea. You know, sometimes the best ideas lie on the other side of the stupid ideas, and you got to go through the stupid ones to get to the good ones. So never reject tossing stupid ideas around. A little like using the root of -1 in your calculations. You really shouldn't exist, but somehow it gets you through the calculation to the other side. Let's try it again. Let's just try it again and again. Again and again and again. Here we go. Another button. Same button. Another button. Whoops. Button came out. I would guess. Let's help it out. Oh, that didn't help much. Oh, he reversed. It actually tuned to the spot. It actually managed to do it. And it's stopped now because it's on the insulating line back here. Well, let's try another one. That's my coffee machine signing off upstairs. Let's try another one. Let's try this one. It's going to break in here, I would think. Okay, stop that. How can you deal with this? Okay, there's a chance of having it up on its end like this, it can't operate. I don't think that's the case. I think having it up on its end, laying it flat, the motor doesn't know the difference. The motor's being thrust forward, no doubt, by the motor magnetism. The motor spins well, but in the end, it doesn't have a lot of thrust, and that's what these kinds of motors are. They aren't very good at power. They also have very low starting torque. Something more to oil. I haven't oiled yet. What more could I oil? And how would that improve the movement? And it's not being restricted by a lack of oil. It comes over and it engages, but then it does this thing. Why is it being kicked back? Shouldn't it come and engage? You know what would keep it there? A strong magnetic force that continue to hold it there. But the force is weak and it's doing this thing. The force is weak. Let the force be with you. Okay, I'm going to stop and ponder. Okay, it only took me 30 seconds to get an idea. The idea is, what if I block the motor so it's always engaged? It's always there. Never disengages. That means you'd have to turn the motor with the tuning knob. I'm going to find out what that's like. What's that like? Okay, stay in there. I need to hold it in, but I can't be putting friction on it too. How am I going to do that? Hold it in the center of the spinning wheel back here. Can I do that? Well, it's not impossible. It doesn't feel that much different. So you'd be doing this. Now, if the set was on and a button was pushed, as soon as you start mechanically turning it, the motor will engage and try to fight you back. But if you don't push any of these buttons, or if you leave the tuning button up here, I believe this is the one, you would engage this, and then you do this, but the motor would still be in there. The bulk of the drag I'm feeling here, a lot of it's coming from what I'm doing here. So this is not impossible. It's not impossible to just permanently push this out, like stick a, I don't know, spring in here, or do something in here, push it out all the time. And then, okay, that's a good thing to think about. I'm going to keep thinking about that while I imbibe some coffee. Okay, I think I can probably set this up so the motor is this way all the time and experiment. And then if it doesn't work, I think I can undo it. That's the main thing, I can undo it. So here's my collection of springs, and I think one like this might be just the thing right in here. And you might say, how are you going to get it in there? I don't know yet. Okay, here's a... So these are less springy, but well, they're still pretty springy. These are pretty strong springs, actually. That's not bad. I think I can work that in there. How would you do that? You have to. So, like most springs, you know, the last turn is flat. I could cut those away. I would cut those away. This is probably pretty hard steel too. That'll make the spring a little bit shorter. Uh-oh, the cat has showed up. Which one is it? It's Bert. Bert is showing up. He'll be up here in a moment, I bet. Okay, this is going to go flying when I'll make it fly into the garbage can. Okay, we'll do the same on this side. Hello, Bert. What have you been doing? Our black cat, for the second time, pushed the bottom of a window screen out, went out onto the window ledge, and the screen snapped back behind her, and then she's outside on the window ledge, can't get in. And of course, we don't know it. It's a back bedroom. We don't walk in there all the time, so she could be out there for hours on the window ledge. You can't jump down; it's too high for her to do that. This didn't cut. You'd think you'd do that once, get trapped outside. You would never do it again. But yesterday, there she was, this panicked look on her face. So there we are. So that's a little bit. This is going to be tricky here. I can't even hold on to it, let alone stick it on there. Bert, what do you think? What do you think? Do cats think? Oh yeah, they think a lot. They are busy trying to figure everything out that they see, trying to understand everything. Don't walk on my keyboard, buddy. So I might be able to work this in. We will see. It might just get so roughed up in the process. much of a spring when it's done. Is there an alternative? Is there an alternative? I'll keep thinking that while I'm doing this. It's a pretty big shaft. I don't know. Just trying to shove a spring onto it is a little bit questionable. Push with this part here. Just got to get one turn on, and then I can twist the rest on. That's the whole idea. Get in there. Ooh, I got to squeeze this tighter. Okay, got them on. Now, it may actually work just right there, but I'm going to try to work it up. How do you do that? You twist it around. You just have to turn it. You just have to turn it. Made an emergency run to the hospital yesterday. Came in from outside, and I had a weird visual effect. It showed up as my eyes adjusted to being indoors. Kind of like, you know, I was staring at the sun, but I did not stare at the sun. And I couldn't tell if I could see it with both eyes or not. And I got quite nervous that, oh my God, I'm having a stroke. So I said to my wife, something funny's going on. It's the kind of thing they warn you about when you're having a stroke. I better go to the hospital. So off we went to our hospital here in Aurelia. And not like the old days. The old days when I was a kid or a teenager or a young adult, walk into a hospital waiting room and there'd be 100 people in there, coughing and hacking, and it used to make me think, wow, this is where you go to get sick. Okay, so what's happening is I'm spinning the whole thing around and around. I'm not really winding it on. So this is going to spin too. I didn't think about that. So we can't have this just hanging out like this. It's got to go on as a spring. How am I going to do this? So if you're American, you might have heard lots of things about the Canadian medical system, and lots of negative things. You probably, in the States, you probably heard a lot of negative things about it. And there certainly are some. You know, if you're not seriously ill, you wait while the more seriously ill people are dealt with. And our hospitals and doctors' offices, man, they are nothing fancy. They are nothing fancy. Often, you know, the walls need a new paint job or something like that. And there's a little bit of maintenance not being performed as well as you might want. Something you would fix in your own house, but it just, like for instance, they take something off the wall, and rather than repair the wall properly, they move on to the next thing. So I'm guessing American hospitals look beautiful inside. They have a lot of money to work with. Well, I don't know what's going to be left of this spring when I get it in there. So the way it works in Canada is that, you know, when you go to the doctor's office or the hospital, there's no money involved, you know, unless you rent a television. I don't know if you even do that anymore. If you're going to be a hospital stay, you could rent a television, and that would be your bill. You'd have to pay, you know, $20 for the TV or something. But otherwise, there's no money involved. There's nothing. Okay, I have this in now. It's not quite pushing it all the way. It may get in here and grind it. It may get caught in there. Let me see if I can just... The last turn is really tight. I'm going to bend it out if I can, so it's not following the shaft into the motor. That's better. But, you know, it's not engaging. It's just missing. I wrecked the spring up so much. Can you respring a spring? I think you probably can. Let me see if I can just put some spring back in this thing. Yeah, I'd like to do that to myself. It's so close, but it's not there. I think I got the right idea, but the wrong, come on, the wrong spring in the end. Hold it there. I'm just trying to stretch the spring back out. If anything, it's worse. It's worse. Got to find out what happens when you run this motor at high speed with a spring sitting there. So we're going to have to try it out. So no buttons pushed. Power on. I should have pulled a rectifier tube out or something too. Doesn't matter though. Okay, here we go. Pushing a button. Grabbing the radio here. Oops. Button didn't stay in. Oh, it's reversed. Oh, slow her down. Okay, right idea didn't work. You had to try the identical spring without cutting the ends off. It's very hard to get it on then. Just pull that out there. Not much of a spring now. It got wrecked so bad going in there. It just lost its abilities. Okay, there's our springs again. This is the one. Is this the one I did? Wow, did I ever distort it? Ooh, 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 ooh. Get my finger chopped off there. Get the whole spring in there, that would be great. But how are you ever going to get it past these end pieces on that shaft? And I can put it on and then try to twist it all the way around, but I don't think I can get these tight last turns on there. I don't think. Maybe I shouldn't think. What if I get a bigger spring, a more open spring? Is this the one that I used? No. This is far bigger, like a far bigger diameter. Okay, so we'll try one of these. Same spring. I won't cut the ends off. Maybe I cut too much off last time. Maybe that's what I did wrong. I should have cut less off. Okay, so we're just trying to just jam it on there and then twist it around. Twist it around this way. To compress it and twist it. This is not going to work. This is not going to work, for crying out loud. Yeah, that's just not going to get in there. Take something off, slide it over the shaft, put it back on. I don't think that's happening. This piece, because of its job, is not screwed on. It's welded or crimped or some kind. It looks like some kind of a permanent attachment there. That's crazy to try taking that off anyway. Can we extend it further than... No, it's blocked right in there. What if we take the retraction spring out of it? Pull the retraction spring out of it. Which hardly has any... With the retraction spring out, and the motor's pull is so weak. I don't know what to think of that. And it's an idea. I mean, the spring doesn't even... I'd rather try to get some kind of spring attachment in here. Some kind of spring, not attachment. Open spring. Okay, I gotta stop and let some ideas come, because I think it's coming down to trying to put another one of these in. Just, you know, first time didn't work. What do you expect? Okay, let's try attempt 2. Now, I did trim the ends off a little bit. The problem is as soon as you start putting it on, it's getting distorted, I think. Okay, now work this up and around. Right. Work it up and around, eh? Pretty sure this will just wreck the spring again. Not with that. What have I got that would grab that? Really, this is really the only thing I think I've got. Maybe. Just use your fingers here. There's probably a method. If I do this long enough, I'll learn some kind of method for doing this kind of thing. That's a method. There's no method visible. Compress the spring. Shove it around and under. Keep shoving. Shove, shove, shove. Shove it, man. Pull it around. I watch, I'm sure you probably do too. You've seen videos of people having car accidents because they have cameras in their cars, and stuff gets on YouTube. I'm always shocked when there's a camera in a car. Clearly there's a microphone, and this car is getting involved in an accident, or somebody's doing something stupid in front of them or something like that, and the driver doesn't say a word. I've seen cars get into significant accidents and not a word. Nobody goes, oh! Like, really, are people that quiet? I certainly aren't. I think that's kind of obvious from these videos. If I'm not talking out loud, I'm talking in my head all the time. Okay, we're getting there. I think I just stretched it inappropriately there, though. And what's with people? People post, I mean, the video's on YouTube, so they took it off their car and they put it on YouTube because I guess they're proud of it, or somehow it got onto social media. And although another car hit them, it's really their fault, you know, for not making room, or they could see the accident coming, but they don't bother steering out of its way, and rather blow the horn and yell at the guy. I've seen a number of videos like that, and I thought, what are you doing? Playing with your lives in a car. You're supposed to stop that when you turn 21. When you're 21, as a man, you mature. Did you know this? The reason 16-year-old, let's call them men, 16-year-old men are dangerous from 16 to the age of about 20, 22, is because they lose their ability. We all did, all us guys, lose our ability to assess risk. And we seem to be, instead of being risk averse, we actually go looking for it. Why would that be? Because by the time we're 20, 21, we ain't taking those chances anymore. And according to some psychologist somewhere that I read, what's happening is, at around the age of 16, boys, males, are getting ready to leave the nest. And leaving the nest, well, doesn't make a lot of sense. The nest is warm, the nest has food, your mom takes care of you. Why would you ever leave? One of the reasons is you can't sense risk. So you don't evaluate your circumstances at home properly. And you go gangbusters to get out in the world. And risk is not an issue. There we go. I got it in there pretty good that time. So between the ages of 16 and 20 or so, men or boys, dangerous commodity. Oh, that's working good. Now it is putting some forward pressure on the bushing here, but I mean the motor only operates very briefly, so what would it matter? It's all oiled up anyway. I think we're going to see this radio work now. So 16 to 20, dangerous time. A lot of kids end up in jail because they can't assess things properly because they're tuned to leaving the nest and taking this ultimate risk of just going out on your own. For girls, it's different, apparently. Okay, now I'm going to get beat up for saying that. Okay. Girls recognize that their mother is like them, and they go through their lives realizing that they can be like their mother, that they're the same sort of thing. Boys, somewhere around the age of 8 or 6 or somewhere in there, realize I am not like my mother. I am not like her, and a fracture begins to occur that does not occur with girls. Now, I'm not telling you this because I believe this. I'm telling you this. I'm sharing things I've learned about, or heard about, I guess really the word there. Interesting stuff. I think this is going to work. Okay, where's that penny? Because I'm up in the bed. The penny, where'd the penny go? I lost the American, there it is. Okay, I'm going to go 5 times. Whoops, I lost it. 5 times. We got a, oh, what is this? This isn't even a Canadian coin. It's not American either. This is, why have I got this here? That looks like a different language I can't read. It's 2000 something. I guess it'd be the year 2000. It's, oh, it looks like Chinese characters in here. I think this is Chinese. It's a Chinese coin. One of my wife's aunts went to China years ago, and this has probably worked its way into our hands from there. So I'm betting the Chinese coin, the Chinese, let's call it a nickel, the Chinese nickel, and the American penny, which hit the floor here. So I don't know where it is, but if in the end I lose the bet, you can come get the penny. Okay, once again, we don't have a speaker hooked up for this test. Power on. Power up. Okay, so to see the mechanical action, you can obviously watch the motor. You can also watch this wheel as it turns. It should do that thing. Let's hurry before the cats get here. Hurry, man! The cats are coming. Okay, here we go. Oh, wait a minute. Yeah, full voltage. Yeah. What happened? Well, I didn't go. Is that because it's on the one there? Let's try this one. Ooh, okay, let's try one a little farther away, maybe. Oh my God, where's it going? Check it out! Hey, hot diggity dog. Let's try another one. Oop, it didn't stick. Whoa, she's really ripping. Very cool. Holy smokes. Okay, we gotta get a reward here. Coffee reward. That's my reward, coffee. Fantastic. We're gonna actually put this down, hook up an antenna, hook up the speaker. We're gonna get this guy. The last thing I'll do is give it a real go. Just in case you're not versed with push buttons, you know, this is the release plate, and the new button lifts the release plate and releases the other button that was pushed, like this one. So if you just go a little ways, you can release them all, if that's what you really want to do. Now the buttons on the front of the radio are kind of free floating buttons. We'll have to take a look at that somehow. They are part of the cabinet, and they're brought into contact with these just by putting the radio in. So what you feel with those buttons, especially after one of these is depressed all the way, like what does the button do? Does it stay in? I don't know. It didn't seem to be spring loaded or anything. It just seemed to be floppy buttons over there. So the main thing is this guy here, you're tuning like this, like, oh, that is a little heavy, gotta admit it. You can see the momentum of the motor, but you know, I mean, you don't sit and tune these radios like crazy, right? You tune them in and listen. It's actually not that bad. That's kind of an interesting feel to it. Okay, put the knob back on here. Okay, antenna's connected, speaker's in. I'm doing the delay thing again. Okay, volume's down, power on. This light's not on because I have this button depressed. Oh, what's it doing? It's flickering. What's happening there? Well, the thing is, the idea I think is that always one button is depressed. That's how the makers of this radio imagined it. There'll always be one button depressed all the time. You have to push a button in to release another one. There's always one depressed. So they made one you depress for normal operation. That's this one. Why did the light go out? Definitely the switching here. So maybe this light is not supposed to be on all the time. Okay, so unless I stop and read the instructions, I'm not going to bother. We are going to operate the radio. What the heck was that? That came out of the speaker just now. Ooh. My radio was moaning. Okay, so we're on broadcast band. What is doing that? So clicking like that, something heating up. How many watts are we drawing? 114, 112 watts. Is the motor stuck on? The motor stuck on block? What's going on here? Who's ticking? Ticking time bomb. It could just be a tube warming up. Oh my gosh, that was a little bit surprising. Okay, don't go looking for more trouble here. Now, listen to the radio. Tune the radio.
And flipping the switch over to a song that we have played more often on this show. And this one is from 2020.
Going down to the stronger stations down here. When I push the button, we'll find out if the silencing thing works, if the radio is silenced. But in fact, if it stays on, it's just as nice because you hear all the tuning stuff go on. Kind of neat. You know, if you're radio crazy like me.
From Howard Levitt and 680 News Radio.
Now the Dynamic Funds Market Minute.
Many companies have changed up their financial guidance as they navigate the trade war and point to economic uncertainties, and that includes the major hotel chains. Marriott, Hyatt, Hilton, and Wyndham all slashed their guidance for the year, although Marriott's cut was smaller than the others.
They did acknowledge there are some U.S. softness for certain customer segments.
Bloomberg senior industry analyst Brian Egger.
There's been some concern about inbound travel from international markets to the U.S., but within those non-U.S. markets, Asia, Europe, etc., they have not changed or in any way trimmed their expectations.
A potential.
And it can happen to anyone at any age. A life event occurs, you lose your job or
Okay,
you
we're going to try the
have
tuning
an
now.
expense that comes up that's unmanageable and it has
So,
that snowball effect.
I want
Everything else
this
starts to
station
become
here.
Unmanageable because
Give me this station
the way
here.
that you set your finances.
Oh, it did silence it. Well, the silencing worked. Oh, for crying out loud. Come on. No, no. No. Stop. Over here, over here. Over here. Something nice for you over here. Come over here. Look at this. Look what I got. Look what I got here. Come on, look what I got. Okay, I gotta throw something on the ground. Look at this! Watch! Not interesting enough? Come on. Look, this is not working out here. You can't be up here doing this. Oh, for crying out loud. Come on. We're talking about radio. Say goodbye. Bye. Out you go. Okay, I banished him. So it's tuned to a station, but there's nothing there. Let's try the next one over. I saw a big spark in here. Oh, sorry about that. You missed the excitement. Let's try another one. Go a little further. Let's try this one. Help it out a bit. No station there. Anyone? Let me read what the station identifiers are and we'll pick a button. I should actually go to a station. CKCL, CFRB. CFRB should work. CFRB 1, 2, 3, 4, 5. 5 buttons in. Those buttons look terrible. 5 buttons in. 1, 2, 3, 4, 5. CFRB. Now if I try to turn it, it's gonna turn against me. Yeah, it did not like that, did it? If you notice, the IF was still open, so we heard a big pop. So you're not supposed to do that. So that's why you push this button, I think. We push this one here. Turns off that light. And I tune all your light. What's this light doing? What's going on here? So of course all these buttons could be in rough shape. Is that light be on? Personally, I don't think I'm going to attempt to adjust all this stuff at the back and make this tune to stations. I think it's better just leave it alone. It's working. It's kind of neat. You can, even if it doesn't find the station. Which one was it? 1, 2, 3, 4, 5. Let's then push this button, because if you attempt this, the motor will operate. Looking to see if we're right near a station. This could be it. This could be 1010 right here. So it'll automatically tune close to the target station.
We've got Kate Collins, lead scientist for Gold Star Canadian Tours. Kate, tell us a surprising fact about polar bears.
Absolutely. Did you know that some polar bears live on sea ice for their entire life? never setting foot on solid ground. Lucky for us, in Canada, we have the opportunity to experience polar bears that migrate from sea ice to shore annually.
That's incredible.
It sure is, and even more incredible is just how easy it is to visit the bears. Come aboard with Gold Star Canadian Tours for our epic one-day expedition up to see the bears this fall. I guarantee you that getting up to Canada's north and spending time with the bears is something you'll never forget.
A one-day expedition directly from Hamilton sounds like a perfect way to visit the Arctic.
It's the experience of a lifetime. Plus, the expedition is completely all-inclusive and great for travelers of
How much?
any age. You don't want to miss out.
Thanks, Kate. Head over to goldstarcanada.com.
I'm not going to tell you on the radio what that might cost. But boy, they're talking about going way up north. Way up there. Okay, pretty happy with the situation. We still have the Magic Eye to look at. We have some final tuning things. I have to put it back in the cabinet. I have to deal with the buttons in the cabinet, perhaps. And but I'm pretty happy. I've got the automatic tuning going. It's really let me pat myself on the back for that. Very good. Okay, well, we'll see you tomorrow. I'll maybe finish this guy right off tomorrow, or it'll be another day after that. It'll be done. Fantastic. Thanks a lot for watching.